Okay. Yeah. So I was talking about the official definition of the image. A Docker image is a file comprised of multiple layers that is used to execute code in a Docker container. An image is essentially built from the instruction for a complete and executable version of the application, which relies on the host OS kernel. So the important thing here is it comprises of multiple layers, and we execute or we provide some of the commands or instructions in the image.
Sir, so yesterday when we downloaded the Ubuntu image, so
Yeah.
that so it uses the underlying Linux kernel of our host machines. But then in that official, it also says that this is a software, when it's like this is a OS copy or something like that. So how is that working?
Yeah, so that's an OS copy, but it does not have any kernel drivers and all, any
Okay.
kernel modules. Okay, so
Okay.
it's very lightweight when you compare to Ubuntu ISO file,
Yeah.
which has all your OS packages, modules, and all the kernel modules as well. That's
Hmm.
pretty heavy compared to the Ubuntu container image.
Hmm.
Okay. Yeah. So yesterday we used a few images from Docker Hub, but there are chances that we may need to create our own image. But why do we need to create our own image? So if we want to Dockerize our own application for ease of shipping and deployment development, then we can create our own image. Now, the second case here can you're not able to find some of the components or service that you want to use on the Docker Hub. In that case, also you can create a custom image for you. Okay. So how do we create our own image? Let's see this. Let's talk about a simple web app class application. So let's create an image for this application itself. Okay. Now, before we create the image, first we need to understand for what application we are creating an image and how the application is built. And the next step, what we need to do is what all we need to deploy this application manually. Okay, so now I'm going to share one GitHub URL where I have this simple web application. Okay, so this is my web application. Now, it's a simple Python application. I have only one file app. So what it does is if the route is slash, it says welcome. If the route is slash, how are you? It says I'm good. How about you? That's all the application is about. Okay. Now talking about this application, so it's built on Python and it can run in any OS provided that Python is installed on it. Okay. Now, so we need to install Python and the Python pip package, and we need to install Flask. Okay, Flask is the server that we are using here. Then, after the installation of these two softwares, then we need to start the web server and run application. Now, once our application is up and running fine, then we can open up a web browser and just verify if this is working fine or not. Okay, so these are some of the simple steps that we need to take to run or deploy this particular application. Now, going back to the PPT, so from if we have to start from scratch, so what we can do is we need an operating system to install Python. So we can take any operating system, let's say Ubuntu. Now we need to update the operating system to see if there are any recent package updates on the Ubuntu. Then we will install Python, and we will install Python libraries and dependencies, which is our Flask. Then we copy our source code, the app.py, which we just spoke about. So app.py must be available inside this operating system, Ubuntu operating system. So we need to copy that code as well. And then we need to run the application. Okay. So these are some of the simple commands that we need to execute. Now let's do one thing. Let's try running an Ubuntu container first, and we will install all these softwares within an Ubuntu container. Okay. First, we are doing it manually. How do we create an Ubuntu container and install some of the software and then run the app? Then, using those instructions, we will convert that to a Docker file. Okay. Let's start by running an Ubuntu container. So if I have to run an Ubuntu container, okay, this is, I'll give it as exercise. Run an Ubuntu 14.04. Run container from Ubuntu 14.04 image. Okay, and in this we are going to also run a web application. So enable port 5000 for external access. Okay, and when you run this container, directly bash into the container. Okay, so given this as a problem statement, what will be the Docker run command for this? So I'll have Docker run. After that,
minus p 5000
dash p 5000 colon 5000. Yes. Then
minus d
minus it
bash
minus it Ubuntu
dash
Ubuntu tag
Ubuntu
colon 14.04.
14.04 and then dash. Okay. So one thing which will not come here is minus, because we want to run it in terminal and using bash. Okay. Minus d will be for the detached mode. So this will be the command docker run -p, and we are exposing 5000 it and then Ubuntu 14.04 bash. Okay. So now all of you run an Ubuntu container with this. I have my Ubuntu container running, so I'll just skip this part. You can run this Ubuntu container by using this command. I'm also sharing the GitHub URL in chat window. If you want to open that and see, you can just have a look. Okay, so is Ubuntu container running?
Oh, yes, sir.
Yes.
Okay, so I hope you're inside the Ubuntu container and able to see something like this, root at the rate container ID. Yeah.
Yeah.
Okay. So now in this, what will be my first command if I go back to the instruction? So we have installed the operating system. Okay. Now the next thing we need to do is update the operating system. So to update the operating system, the command which we can use is apt get update -y. Okay, this is the command which you can run within our container. So run this command.
Sir, when we are downloading this Ubuntu image inside a container, so essentially our architecture now becomes the kernel, the Docker, and then within the connector, within the container, another OS layer.
Okay, can you repeat that once again?
Yeah,
So you're
so when we
telling,
so like when we are downloading this Ubuntu image for a container, so the whole architecture, so we have an extra OS layer, so it is like acting like a virtual machine.
uh, in a way, yes. So you have this Red Hat operating system, right?
Hmm.
In your Linux VM.
Yeah.
So this Red Hat has two things or two parts in this. One is
Okay.
OS software, which is your which is providing your Yum repositories and all of that. And
Hmm.
then you have Linux.
Kernel.
Okay.
Yeah.
Right now
Yes, sir.
you have this OS software layer, and this becomes your Docker host.
Hmm.
On top of you have some hardware which is running or which is providing
The RAM, yeah.
RAM, CPU, disk, and all.
Yeah.
Okay. On this
Hmm.
hardware, you have this Red Hat, which has two parts: OS software and
Linux.
Linux. Now, on top of this, top of your Red Hat, you're installing Ubuntu container.
Continue.
Okay. Now, when you install this Ubuntu container, so it has only the OS
Software.
part.
Okay.
It uses same Linux kernel.
Okay.
Okay. So now what we are doing is on top of this Ubuntu container or within this Ubuntu container, doing
So Python.
and Flask and run our web application. So
Okay.
it is like this.
Sir, and like one more basic doubt. So one container can have only one image. It can't use two images.
Yes, correct.
Okay.
So you can create a container with an image.
Hmm. Okay.
So with one image, you can create multiple containers.
Okay. Okay. Got it.
Okay. Uh, okay. I'll just allow Nishant here. So, Nishant, we were just running a Docker Ubuntu container. So you can get started an Ubuntu container using this command, sending it as well. Okay. Now is the update of the it up hyphen y.
Prabha, I am getting some error. Command line option G from get is not known.
Okay, can you send the screenshot?
Yeah.
Anyone else also? No? Yeah, Priyansh, you can send the screenshot.
I have sent it on chat.
Yeah. Okay. Between apt and get, there should be no space.
Oh, okay.
Let me also put this here on chat. Okay. So first we update our operating system using this command. Then we install Python. So if you have to install Python, then I can use this command get install hyphen y. Okay, and I'm just going to put all the commands so that you can execute it. Then after installing Python, I in this I need also to install Python pip. So what I can do is add another command like this and type hyphen pip, or else directly by providing a space, I can give a command like this. Okay, Python and Python pip I have installed. And next I need to install Flask. Okay, so after installing Flask, we reached this stage where we have installed all the Python libraries and dependencies. Now we will need to copy the source code. Okay, so I'll wait for you guys to reach at this. Now these are the two commands which you need to execute. Sending it on chat as well. Okay. Now I'm also going to execute in my Linux system. Done. Is this all done?
Yes.
Yes.
Okay. I think for me it's taking time. It is. Now next thing is we need to copy source code. Okay. So to copy our source code, what we can do is we can directly create a file and put all the content of this app.py. So that is one option which I have. Or else what I can do is I can install Git by typing this command. So I can type yum, sorry, this is so app-get install hyphen y git, and then I can do a git clone of the repository, right? So I can execute these two commands that will copy, basically put my application code within this Ubuntu container. Okay, so I'm also going to paste these two commands.
Yes, sir, done. Sir, I had one more question again. So
Yeah.
in the container, so how is memory is allocated dynamically every time? Like, so it has access to the whole memory pool and based on our need, the memory just gets allocated to it.
Right. So
Okay.
right now we are not restricting any memory for the
Okay.
container, but
Hmm.
there are ways you can restrict the memory usage. We will talk about that as well.
Okay.
So as of now, your Ubuntu container or any of the container which is running can utilize the entire VM memory.
Hmm. Okay.
Okay. So now my application code is also downloaded here. So the next command which I have to execute is, so we have done these all steps. Now the last step is only remaining, which is running the application. So to run the application, the command which I need to execute is this, which is flask underscore app.py flask run, and then the host. So I'm telling the host as 0.0.0.0, which means all IP addresses. So finally, I run this particular command. I have sent in chat.
While running this command, I am getting an error. Could not import app.
Yeah, even I am getting
Okay,
same error.
okay. So, okay, got it. What is the issue? So you need to, when we do a git clone, it basically creates a folder with the repository name, and then it downloads all the code here. So you have to do cd web app. Okay, this is our repository name.
So now it's working.
Okay, so now you see that application is running something like that,
Yes.
or
Yes.
running on http://localhost running, right? So what you can do now is you can check your IP address, the VM IP address and colon 5000, and then you will see that your application is running. So we have, with this way, we made our application working deployed using a base Ubuntu image. Okay. So do you see that application running?
Yes, sir.
Okay,
Yes.
great. So now this is, suppose this is our custom built application, and we wanted, this is our custom built application. So obviously the image will not be available in Docker Hub. So what we are doing here is we are making use of some base image, which is Ubuntu 14.04. And here we are installing all the dependencies which are needed for our application. Then we are copying our code, and finally we are running it. Okay. So all these steps that we are doing, we can convert it to a image. Okay. Now let's see how do we convert it to a image. So now that we have instructions, I'll create a Docker file using these instructions. So first is OS, then update OS, install dependencies, install Python depend, copy source code, and then run the web server. So all of you, what you can do is now you can get out of that container if you want. So I'll just exit this. Okay. So here I'm going to exit from this container. Now, once I exit from here, you will be in your root, your PC or VM account. Okay, so exit from there, and I have this. I'm just listing out the folder. So what I'm going to do is I'm going to create a folder by name simple. Okay, or else rather, let me put it this way. So I'm going to clone my repository over here. I'm doing a git clone. So first I'm taking my application code. Okay. Now I have my application code here. I'm going to do a git clone in my VM. So you have your Red Hat VM. If Git is not installed, you can install it by yum install git. Okay. So were you able to clone this project in your account, in your VM?
Okay. Do we have to write sudo ahead of it, because I'm getting that error while loading shared libraries?
Yeah, even I'm not able to install Git by using sudo also.
It's
Even
working
by,
with sudo for me.
okay. So can any one of you share the screen? We'll have a look.
I'll share my screen. Sir, is my screen visible?
No, not yet.
1 second.
Okay, how many of you are getting error while installing Git? Okay.
I'm installing Git
Git is
now.
getting installed.
So,
Okay.
and git clone. So I don't have to add sudo before git clone.
Yeah, you don't have to. Yeah.
Git remote HTTPS.
Yeah, while cloning, I am getting the same error.
Okay. Do a C git remote HTTPS file. Okay.
With
Now
sudo, it's working.
do ls with sudo. It works. Okay. Do a
Yeah,
sudo and
Now it's working with sudo.
okay. Okay. Great. So try with a sudo, then it should work. So I'm sharing my screen once again. Let me know if you're able to see. Okay, so now after the git clone, what will I do is I'll just cd or get inside that folder. So that is cd simple web app flask. Okay, now if I do a ls here, I see my application code. So here what I create a Docker file. So file here, and there will be no extension as such. Just type vim. Vim is an editor, so vim space docker file. Okay, with just create a docker file. Then now what I'm going to do is I'm going to instruct my docker file that take images, take the base image as Ubuntu. Okay, so this is my first instruction. Now once I'm done. So I'm going to instruct my Docker file to run some of the commands. So which is run apt get update and then run apt get install Python and Python pip as well. Okay. I tell my Docker file to install Flask and Flask MySQL is actually not needed. This you can skip it. And then I'm going to copy the source code of my application to /opt/source code. Now this is just a example which I'm showing. We will create a Docker file for our simple web app Flask application. Okay. Now I copy the source code and then instructing my Docker file again to run this command, which is Flask app, and providing the path of my source code, which is /opt/source code/app.py, and then Flask run. With this, I'm instructing my Docker file to run this command at the end. Okay. Now this is my Docker file. What are these commands? We are just going to talk about it. Now, file is ready. What I can build my image using this particular command, which is -t. -t is for tag. So I'm tagging my image with Prabhav Agrawal / my custom app. This is tag or name for my image, and giving a dot meaning take the Docker file from the current folder. So that's what I'm telling my Docker build command. With Docker build command, what we can do is we can build our Docker images. Now, once my Docker image is built, I can push it to my Docker Hub account, which is by using this command docker push Prabhav Agrawal / my custom app. Now, by default, I won't be able to push it to my Docker Hub unless I go to my Docker Hub account. So to log into your Docker Hub, the command which you can type is docker login and use equal to your Docker Hub username. Okay. Let's take a closer look at the Docker file. So Docker file is a text file written in a specific format. Okay, specific format meaning what Docker can understand. So that is instruction and argument format. Everything on the left is an instruction. So this is from run, copy, and entry point. These all are instructions. And Ubuntu is an argument. That means we are specifying what base image we want for our Docker file. So now here run, copy, entry point are the instruction. Then app update and copy this dot/opt instructions. Now let's talk about this line by line. So first line is from Ubuntu image. Okay. So from I'm specifying. So from defines what base operating system or what base your container or your Docker image will take. Okay. Now every Docker image must be based off of another image, either an OS image or any other image like Tomcat or Redis or MySQL. So you can use any other image as well. If I want, just a moment. Okay. So if I wanted to use, if I was running a Java application, so one option is to start from the base image Ubuntu and install Java, Maven, and Tomcat on top of it. or else I can directly take a Tomcat image and copy my application. So that's another approach for it. Okay. Now this image, when you take the base image, try to take only official image. Like you get the official tag in the Docker Hub, right? So take the official image only when you're trying to create a custom image. Now, next, I'm going to talk about another instruction. So the next set of instructions is your run instruction. So the run instruction instructs Docker to run a particular command on those base image. So at this point, Docker runs the apt-get update command to fetch the updated package and install required dependencies. So all these my run commands are actually the commands which I'm instructing Docker, like we are doing here. Okay, so these all go under the run command. Now to copy my source code, what I did here is I installed Git and then cloned my Git repository. So I can do this with the run command as well, but we have an additional option in Docker to which is our copy instruction. Okay. Now this copy instruction copies my file from local system onto the. In this case, the source code of our application is in the current folder, which is dot, and I'll be copying it over to the location /opt/source code inside the Docker. So if my application code was in this folder rather than the uh, current folder, if the application code is in /root/simple web app, so what will be the instruction over here? So it will be copy /root/ space my /opt/source code. So this is like your folder location on Docker host, and then folder location on the Docker container which you're expecting. Okay. Then we have entry point. Finally, entry point allows us to specify a command that will run when the image is run as a container. Okay. So this is the command which will be executed when your container clear. So these all commands, the from Ubuntu and install packages and all will be a part of the Docker image itself, and this command will only run when you run a container. Now, is this clear?
Yes, sir.
Yes.
Okay, so now we will also make our Docker file, and we will try to build it. Okay, so now opening my instructions, which I have here. So it is these all instructions I have. Okay, and now opening my Docker file. I'm just putting a dummy content here for now. Okay, so now remember we are in our simple web app Flask folder, and here itself we have our app.py code. Okay, our application code, and we are creating a Docker file over here. So the reason I'm telling this once again is that will reflect in our copy command. Okay, so now again going back to my Docker file. Okay, so I'll put the instruction first, which is from and run. So I may have one more run command and then the copy command and then the entry point command. Okay. So now coming back here. So what will be my from image?
Ubuntu colon 14.0.
Ubuntu colon 14.04, right? And then next run instruction, what should I provide here?
Apt get update -y.
Apt get update -y is what I can provide. Then here I can provide the next instruction, which is apt get -y install Python and Python pip. Okay, now if I want to provide this as one single instruction, not as two instruction, I can provide a double and here, and I can provide apt get install -y and then Python pip. Okay, so this will install my this will update my operating system as well as install some of the dependencies. And then here I can provide pip install Flask. Right now, in the copy command, what will come? Suppose if I want to copy that to /opt. So here, what should I provide?
I think dot then space -opt.
Okay, dot is correct. I want to copy that to /opt. Okay, so I just provide /opt. Now in the entry point, so entry point is the important instruction here because the command which you specify in entry point will done while running the Docker. Okay, when we run this image or when we run a container from this image, you will also see that. Okay, so in entry point, what do we specify?
Flask app _app equals to /opt/app.py, then Flask run host.
Right. So here it will be /opt/app.py. Okay. Now this will basically form my Docker file. Okay. Now my Docker file is ready. I'm just going to save it. So did you also manage to create a Docker file like this in your?
Sir, 1 minute, 1 second.
Yeah, if not, you can create it now. I'll be in this screen for about 2-3 minutes so that you can create this Docker file.
Yes, sir. Done. And also, like all of these, like for the image from Ubuntu, it is case sensitive, the image name.
This one?
Yeah.
Yeah, this is case sensitive. Okay, so for other people, is it done? Have you created the Docker file?
Yes.
Just a minute.
Yes.
Okay, great. Now I'm going to save this Docker file, and then we will see how do we build our image using this Docker file. Okay, just to be on a safer side, I'm just doing a cat Docker file to see the contents of my file here. Okay, now
While
suppose
saving,
here,
sir, while saving, I'm getting this error. Docker file can't open file for writing.
Yes, I'm also getting this.
I think you'll have to provide a sudo while writing that particular file.
Okay, so how do we
Save
exit
it.
it?
You can type escape code q exclamation.
So, like right now I'm in the command mode. So in the command mode, or do I have to type it in the insert mode?
In the command mode, you have to type q
Yeah.
colon q exclamation. Okay, and in the interest of time, you will have to write that once again. So I'm going to put this in the chat window.
Sir, I'm getting recording. It's not exiting.
Okay. Okay, can you share your screen? We'll have a look.
Yeah. Sir, is my screen visible?
Not yet.
So 1 minute. So now,
Mm, it's loading now. Yeah, I can see that now.
yeah. So
Hit escape.
I hit escape. It's still showing recording.
So, okay. Try pressing insert.
Yeah.
Okay, now escape
Yeah.
colon
Yes.
q exclamation
Okay.
colon q exclamation.
Thank you. Exclamation. Ah, okay. So now I'll have to
Open
do.
this with sudo. Yeah. Okay. Anybody else having any other issues? Docker file.
Okay.
Any other issues, guys, while creating the file?
No.
Fine. So once my file is created, what I can do is I can build my image using the Docker, which is Docker build. Okay. Before that,
Sir, can you share your screen?
Oh, okay. Is it visible now?
Yes, sir. Now I can see.
Okay, great. So I was telling now we can build our image, Docker build command, and then provide the tag. I'm telling -t as a tag over here. Now here, Prabhav Agrawal, this is my Docker Hub account name. So if you see here, hub.docker.com is that's closed. Okay, I say this as hub.docker.com, and here this is my account name for my Docker Hub. Now that's why I'm specifying this as Prabhav Agrawal / and then my image name. But if account as of yet, then also you can build an image. Okay, so right now we are going to tag it with a local image name. So I'll just say my custom app. The only thing will be I will not be able to push this image to Docker Hub. That will be the only challenge over here. Otherwise, there's no other problem as such. Okay, now do remember to put a dot here because that dot indicates where your file is present. Okay, so I'm putting a dot at the end here. If I want to provide the explicit path of my Docker file, then I can provide -f and then /root/app/docker file. Something like this do if I want to provide an explicit Docker file path. Okay, so I'm saying this Docker build -t for tagging my image. My custom app is the name of my image, and then dot is for the Docker file, and then I hit enter. Okay, so once you hit enter, you will see certain steps getting executed to build the Docker image. Now, as you can see, step 1, it says from Ubuntu 14.04. Step 2, it is running some of the commands to install software. Similarly, once step 2 is done, it will execute step 3 and 4 and 5. Okay. The reason it is having 5 steps because we have provided 5 instructions to Docker. Okay. So is it built for you guys?
It's building.
Okay, it's building. We'll wait for some time here.
It built for me.
Okay, fine. So how about other people? Built?
Oh, yes, successfully built.
Yeah, but
Yes, sir.
Okay. So now I wanted to show you that Docker follows a layered architecture while building the image or while running the containers also. Okay, so the first instruction is from to image. Now it will be followed by the second instruction, which is our run image. Now here each line of instruction creates a new layer in the Docker image with just the changes from the previous layer. So what do I mean by here is my first command, it is base Ubuntu layer. So as I can see in the CLI as well. Now my second layer will not rerun the Ubuntu command. It will just record the changes which is specified in the second step. So which will be my second step, which is change in the apt package. Then change in the pip package. Then fourth will be copying the source code. Then fifth will be finally running the application. Okay. So now, since each layer record only the changes from the previous layer, it is also reflected in the size as well. So if you look at the history of the Docker image, if you type this command Docker history and then the name of your image, which is my custom image or whatever name you have provided, you can also see that in the size of that. So as you can see in this image, my Ubuntu layer is 120 MB and the package layer is 306 MB. Pip is about 6.3 MB and source code is very small in bytes, which is 229 bytes. And then the entry point actually does not contain any of the disk space, so it is 0 bytes here. Okay, so if we want to see the size and see the layered architecture or approach of Docker, we can run Docker history and then the name of our image. Okay, now in case in this a particular step was to fail, let's say step number 2 failed, or let's say step number 3 failed. Okay, so you work to fix the issue and rerun the Docker build command. Now Docker will not build it from the scratch, okay, because our build failed only in step number 3. So what Docker will do is it will utilize the first build layer and the second build layer, which is Ubuntu and apt package. It will not take time in building this again. It will just take the changes of layer 3, 4 and 5. So that's how the Docker build is fast. And if at all you um, build or make any change in your Docker image, let's say you add one more instruction over here. So Docker will utilize the previous 3 instruction and only execute 4th, 5th and 6th instruction, not the previous 3 over here. Now, in a way, by using this approach, Docker builds are comparatively faster. How? Any guess? Okay. When we develop our software, what do we change typically? So we only change the source code of our application, right? Most of the time, the operating system or packages that we are using remains the same. So if I'm working on HappyTrip, I'm using Java and Maven and Tomcat. So the installation, the software remains the same. It is only the source code which I'm changing. So that's why Docker builds are comparatively faster, because you do not have to build all the layers. You just build the Docker source code layer. Clear? So this is about the Docker images. Now I have
So, sir, while installing this one, in between, like it shows like removing intermediate container, then removing another intermediate container. So how is that happening? Like in
where
order,
is that showing?
yeah, towards my end, like before step 4 on 5 copy, it says removing intermediate container, the container ID. Then after the copy command, it assigns a new container for the entry point, then it assigns a new container and removes the previous one.
Okay, can you show that? Can you share your screen and show?
Yeah. Just one second. Sir, is my screen visible? Is my
Yeah.
screen visible? So
I
1 minute,
got
I'll
it.
try. Yeah. Now?
Yeah. So
Yeah. So these last few commands.
okay. So it says successfully installed Flask intermediate container and then removing intermediate. Okay, I'm not pretty sure about this. I haven't noticed it before, but what I'm mm, assuming here is Docker creates a temporary container here to
Uh,
execute or perform these things, and then um, it
so,
installs or does this
okay.
task.
Okay, so for all the run commands, it is in one container. Then after when it copies it, it just removes that container like that.
Yeah, yes, yes. Maybe I'm just assuming this.
Okay.
However, I'll just get the correct answer for it and will tell you tomorrow.
Yeah. Okay, sir.
Yeah, great that you brought it up. I haven't noticed it before. Okay,
Okay.
so
Sir,
yeah,
I had one doubt. Let's say if we want to clone some Git repos, so we can do that in the Docker file as well, right? Instead of using that copy space dot command.
yes, you can do that within the image itself while
Okay.
providing the Docker file.
Oh yeah, and yes, this copy command will take the in this case in this current Docker file. So the copy command is taking the current clone repo which we have in this directory to the /opt folder. So we can see that opt folder as well, right? But I'm not able to see that.
Okay. /opt folder is within your image, not
Okay.
in your Docker host. Okay. So we'll see that. We'll see where does that /opt comes in a while. Okay.
Yeah.
So now let's do one thing. Let's run our run an image, run a container using this image. Okay. So now, if you have any containers which is running like Ubuntu container we had, you can stop it. And then to run this, run a container using this image, what command can you type? Let's say I have the same use case, enable port 5000 by running this container. Okay, and run it in detached mode for now. So what command can I type? Docker run. Okay, to enable port.
SP 5000:5000.
Okay, 5000:5000 for detached
minus
mode.
minus D.
Okay,
Prabha Agarwal
and
slash.
what should be the name? Okay, I didn't give this while building the image. I
Okay.
Okay.
just
My
gave this.
custom.
Yeah,
Okay.
my
My
customer.
customer. My customer.
Okay, so I say Docker run slash sorry Docker run -p 5000:5000 -d then my custom app. So all of you run this as a command and just try to browse the application. See if that works.
Yes, sir. It seems to be working.
Fine, right. So now you notice that for running this container, it would not have taken a lot of time, right? Any guess why is that so?
Because the image is locally existing.
Yes, the image is locally existing. That's why it is not taking a lot of time. Now, the coming back to the question, where is that slash opt folder, right? Or where is our application code going? So let's get inside the container. So to get inside the running container, what command do we use?
Docker attach and container ID.
Okay, yeah, Docker attach will attach to the console
Exec.
of the container.
We'll use
Yeah.
exec container
Use
ID
exec
and,
container ID
hyphen IT.
-IT bash.
Exec hyphen IT container ID, and then you have to provide bash. So get inside this container, and when you get inside this, type cd/opt, and then you can do ls.
Yes, sir. It's there.
Yeah. So when you do a ls, you will see that all the files related to your application, what we copied here, which is copy dot, and then so all the files which you copied from the current folder will be present in the /opt folder. Okay. So clear about this? How do you create your custom image and how do you build it?
Yes, sir.
Okay, great. So now we will be doing an exercise here. Now in this, we've already, okay, this one I wanted to show, but I explained this, right? When you run the docker build command, you will see the various involved and the results of each task. So this way, all the layers built are cached by the Docker. In case this particular step failed, it will not start from the beginning. It will start from directly step number 3 because it will be cached. Okay. So now let's do one thing. Let's try to see this behavior. Okay. So in your Docker file, what you do is suppose this is your Docker file. I'm just copying the content. Okay. Okay. So suppose this is my Docker file, and let's say I do not want to copy the entire folder. I only want to copy app.py. So make this change and then notice the difference. So when you copy app.py, you need to provide a slash over here as well.
This change in the Docker file will make outside our container in our host location, right?
Yeah. So when you run the container means you have to make this change in your Docker file outside your container. So
Yeah.
you can exit from the container, and if you want, you can remove that container.
Got it.
So did you make that change?
Sir made it.
Okay.
Yes.
Now, okay. Can anyone of you share the screen? I think it's taking a lot of time for in my system to build.
Okay, I'll.
Okay. So what I wanted you guys to make is one change in the fourth command, which is copy. Now, if you see this from Ubuntu and then second step and the third step, it says using cache. So it did not actually build the entire steps again. So it only changed the fourth and fifth step, not the entire one. That's what I just wanted to show you by making this change. Okay, so clear about this? Now, what you need to do is, as an exercise, I'll just share my screen once again. Okay, so I'm sharing my screen. Here, what you have to do is create a Docker file for the following applications. I'm now showing you one first application, which is your simple web app color. Okay, now create a Docker Hub account. It is more or less similar to how you created the Git account, and then push the Docker image into your Docker Hub account. Okay, I'll just put the instruction to push the images and all. Okay.
Sir, do we have to start now?
Yeah.
Yeah.
I thought you had already started.
I thought, sir, the link could you share?
Oh, okay. I'll just share this.
Yes, sir. It post.
Working, right?
Yes, it's working.
Okay, fine. So next, I'm just uploading one file. Just give me a moment.
So can you display that push command?
Yeah.
Prabhav, I am getting this error. The command apt-get update y and apt-get install python pip returned a non-zero code 1.
Okay. Can you share your screen?
Yeah.
Okay. Show the Docker file. Okay, run this once again. Means run the build. Yeah.
The same error.
And this shows in which step. Go up here.
I think this is step 2 itself. Yeah, step 2.
Okay. Go down. In the Docker file, try giving update and command separately.
Okay.
Yeah, just wanted to see in which command it is giving an error. Yeah, 2 separate run commands. Okay. How about other people? Is it done? The simple web app color.
Yes.
Okay. So now I'll share my screen once again. And now you have to make the Docker file for this application, which is Java application, and the name is time tracker. I'll share this repository URL. Before that, let me show you what needs to be done. So in HappyTrip, you saw, right, that it generates a WAR file. So that same WAR file, we need to deploy it to the Tomcat web apps directory, right? Now, this time tracker application is also built on Java, and it needs Java and Tomcat 9 to run the application. So in this, I have created a dummy Docker file, and this Docker file is completely wrong. You can change the from image as well, run instruction and CMD or entry point expose. Whatever you want to change, you can change in this Docker file, or you can completely delete this file and recreate your own file. Now, I'll tell you what has to be done. So in the web folder, you have a target folder. Now, target is usually not present in SCM. Just for this exercise, I've put in target, you have this WAR file. So this WAR file needs to be deployed in Tomcat. Okay, so that's the whole goal of creating the Docker file. Clear about this exercise?
Sort of, yeah.
Okay, I'll tell you once again. So in the simple web app Flask application, so we had so in simple web app Flask application, we had this app.py, which we were copying to the Docker image. Similarly, here we have this WAR file which has to be copied. Now, you know how does Tomcat work and where do we have to copy? So I don't have to tell you that. Now, the second thing is this is a Docker file, a dummy file. You can change any of the instruction here. From image can be changed, or run instruction, or any of the instructions you can change over here. Clear about this?
Yes, sir, clear about that.
Yeah. Okay. So Priyansh, can you share your screen again? We'll have a look at the issue.
Yeah, now it's coming in the third step. So it's with the Python and Python pip.
Python. Open the Docker file. Okay, here you have not given the Y option. That means the default yes if any of the command is needed.
Yeah.
So after the install, just put a -y.
So like here it's asking after this operation, it will choose Y then.
Yes, Priyansh. So if you give -y, it will by default select yes for all these installations.
Okay. Yeah, now it's building.
Okay.
Okay. Thanks, Rob.
So is that done? Time tracker application.
I'm doing just 1 minute.
Okay. Yeah.
Prabhav, can you tell us once what we need to do the time tracker? I just got completed with the last one, simple wave color.
Yeah. You want me to explain the The problem statement, right?
Yeah.
Or, okay. So in this time tracker application, this is a Java application.
Can you please share a screen?
Sorry. This time tracker application is a Java application, and it uses Tomcat 9 to host the application. Okay. Now here in this, you have this target, and under target folder, you have this war file, which needs
Okay.
to be deployed. Okay.
Okay.
Now, here is a dummy Docker file. In this, some instructions are mentioned which are not relevant, like from Ubuntu image. So you can take the change the image if you want to, and
Okay.
change the instructions and all other things basically. Or you can delete this Docker file and create your own Docker file.
Okay. Fine.
Okay.
Yeah.
Sir,
Yeah.
yeah, I kept a screenshot of it. Can you see if that correct? If it is correct?
Yeah. Okay. Yeah. Yeah. Does the application work with this?
Sir, I
Did you
am not.
try building?
Sir, right now I'm not able to run with sudo access, so I don't. I I don't have sudo access yet, so I'm not able to git
Oh,
clone
okay.
it. I
Okay.
requested them for sudo
Sudo.
access. I'm waiting for.
So, sir, like for me, the time track, I just gave it dot backslash web slash target in that same thing. And but it's the copy, it says that the war file is cannot find the war file. And instead of like, yeah, and instead of install OpenJDK, I have written install default hyphen JDK hyphen Y for Java.
Okay. Okay. Yeah. Okay. So let me tell you one thing, all of you. So the reason I gave a dummy Docker file was to confuse you guys. Okay. So we do not have to necessarily use always an base operating system file. It need not to be Ubuntu always or any of the operating system. So uh, if you search for Tomcat 9 or Tomcat in Docker Hub, you will get a Tomcat 9 image also. So Tomcat 9 also can be used as a base image. In that case, you don't have to install Java or Tomcat or any of the operating system files and all. You can just use that as base image and copy your var file so that there will be only two instructions, from and copy.
Copy. We'll try that.
Yeah. Prayag, any idea when are they going to give the sudo access?
Uh, no, sir. They told me to raise a ticket. I raised the ticket. I think I'll just have to wait. I also asked them to check the ticket.
Okay.
Yeah. Probably it has
This
to be done by
isn't
today.
that. Okay. Okay. So you have AWS account, right?
Yeah, I have AWS.
Do you have AWS account?
Yes, yes.
Okay. You created a free trial one, right?
Yeah,
Just before today's, means the DevOps session, correct?
yeah, yes.
Okay. So just quickly log into your and quickly
Uh,
share your screen. In the meantime,
sir,
others are doing this exercise.
I think someone has messaged me regarding this VM. I think if
Okay.
he's able to resolve it now, I won't need the
Okay.
AWS.
Okay. Okay. Fine. Hello.
1 minute. I was trying some other this. My copy command is failing. I just looked at your copy command now. I'll try it.
Okay.
Yes, sir. So now it's working. Sir, why do we have to specify that root.var in the end?
Okay, yeah, root dot var at the end, if you do not want, you can skip that part. So basically what I'm doing here is,
No, sir, I
uh,
skipped that, but it's not copying.
okay, I'll tell you what I'm doing here.
Okay.
Okay, it does not copy at all. It copies, but with a different name.
Sir, I tried the first one while copying. In the first command only, it says that cannot locate this source file not found.
This source file.
Yeah, but I had written the same command only.
So when you're telling when you type this, only
Huh.
this,
Yeah,
it
I'm getting
says can't
source file not.
locate.
Yeah.
Okay. Right. So here I'll tell you what am I doing in this, and then we can try your command and see what is the error.
Okay.
Okay. So in this case, as you can see, my target folder is inside web,
Hmm.
and inside this folder I have this war file.
Yeah.
So I do not want such a big name for my war file.
Yeah. So replacing it from star dot. Acha, okay. For there, you're replacing this name with root dot var.
Yeah. So here
Okay.
I'm replacing with root.var. Okay,
Okay.
that's one thing. But in this, I'm not sure that which war file I will get. So
Ah,
basically,
we're
this
using star.
0.5.0
Okay.
is the number which you get from pom.xml. So it can be anything when you build. So
Hmm.
basically, for taking that war file of any number or any name, I'm using star.var. Okay. And here in the Tomcats directory, I'm replacing with root.var. Instead of root, if I give time tracker, then my
Ah,
application will be accessible at slash time tracker.
okay.
Otherwise, if I give root.var, meaning in the root directory itself, I will be able to see this.
Okay.
So without putting slash time tracker at the end.
Sir, I'm getting a error. I've sent it on chat.
Okay, I'll just have a look.
So after this command, I just did the I built my this file and I did docker run. So I don't have to specify the port, right? Because while I'm
Then
okay, so because while I'm specifying the port, it says that the port has already been allocated.
okay. So port 8, what is the port that you are giving here?
8080.
Okay. Hyphen P 8080 colon 8080 is what you are
Yeah, yeah,
saying, right?
yeah. Okay, actually,
Okay.
I had first I had installed Tomcat. Okay, so while in running the Tomcat image only, I had allocated 8080 for that. So is that the
Yeah.
reason why it's not?
Yes, that's the reason. Port is conflicting. So you can type 8081 colon 8080.
Okay.
Mahima, I have sent you. Okay, can you share your screen? I'll tell you few commands which you can execute.
Yeah, I'll share.
Okay. Type df here.
DF.
Yes. Enter. Okay. Okay. Can you type Docker images? Mm, yeah. In this, remove some of the images which are not getting used. Like you can use one of the Ubuntu image, then Docker Whales image you can remove.
How do I remove an image?
Docker RMI,
And the
and
image
then
ID?
image name. Yeah, image ID you can use. You have to stop the, okay. Do Docker PS hyphen A. Okay. So you can remove the containers which you don't want. So for that, you can type Docker RM hyphen F, then container ID. So you can delete multiple containers by providing a space between container IDs. Delete the containers, whatever you're not using.
Okay, after that, do I also have to remove the images?
Yeah, remove. Actually, basically, the space is not getting full.
Mm-hmm.
So that's the reason we are just deleting some of the containers which are not used.
Okay, so I don't need to. Do I also need to delete images after this, or like
Yes, you
should
can
this work
delete the images also.
also?
Docker RMI,
Okay,
and
yeah.
then Yeah, delete some of the images which you're not going to use, like my custom app and all those
Yeah,
things.
okay, I'll do that.
Yeah.
Yeah,
Okay.
thank you.
Okay. Okay. So now run. Able to run the time tracker. Right?
Sir, 1 minute, I'm
Sir,
running, but it's the web page. I'm not able to see it.
Okay. Can
sir,
you?
in my case, I'm trying to run, but I'm getting an issue. OCT runtime create field. I've shared the screenshot.
Okay. I'll just check that. Image name you have to give at the end.
Okay.
Madhur.
Sir, I'll share my screen.
Yeah.
So this is my time tracker. So I built this image. I think it's running, but
Okay. Yeah, it is running. Can you open a web browser and try?
yeah, 8080 port I'm getting. Nothing.
Doesn't talk.
Yes, sir, same issue.
Okay, let me just check in my system.
If we just run 8081 on the port, it says this is a super simple web page. We are getting the
Yeah,
response.
yeah, that's the one. 8081 try.
Okay, so I'll just exit and remove that image, right? Okay,
No, show me the Docker file actually. Here in this case, 8080 should also work. Yeah, Mother, if you're getting that this is a super simple web page, then for you it's working fine.
Yeah, but sir, I had one doubt. Like we had deployed root.war file, so we don't have to specify the path after 8081, like slash root dot slash root.
No, so when you put any of the var file with the name root.var, then you don't have to specify. If you're
Okay.
specifying as time tracker.var, then you may need to specify over there.
Okay.
so this is my WAR file.
Yeah, just checking that. Okay, so you're copying dot web target. Okay, so this looks okay. User locale, Tomcat, server. Okay, so there it has to be Tomcat instead of Tomcat 9. Enter means save it.
Oh, I didn't open it using sudo. So what should I
Oh,
do?
okay.
Only Q.
Q
Ex-
exclamation. Okay, fine. So I'll just send the correct Docker file. I think this is the correct one. You can run it. Okay. Anybody else having issues while running the time tracker application?
Okay. Now. I'll try with 8081.
Did you build the image
Oh,
once again?
oh, I forgot that part. Sorry. So that was the command sudo docker build.
Mahima, were you able to run that after deleting the images?
Yeah, I'm trying. I'll just let you know.
Okay.
Yes, sir, now it's working. Thank you.
Great. So when you make any changes to your Docker file to to get it reflected, you need to build your image once again. Okay. Okay. Clear? Any other issues? Anyone?
So it got built for me. Thank you.
Build from. Oh, okay. Great. Okay. Fine. So now we can take a break of 15 minutes, and I'm also sharing one of the exercise which the web exercise which you have been doing for Docker commands and Docker run. Okay, so I'm sharing the web URL also. This exercise may take about 15 minutes, and you can take a break of 15 minutes. So we can resume somewhere around 11:55 or so. Okay.
Yeah.
Yeah. Okay. Hello. I hope you started doing the exercise.
Sir, just start.
Okay, great.
Yes, sir, just completed.
Okay. Great. How about others? Done?
Yes, sir, done.
Okay. Great. So these exercises you were able to do, right? Practice. These are practice exercises just to make familiar with the commands and all. Okay. Now I'll share my screen again. Let's look at some more concepts in the Docker file. Okay. So now talking about command versus entry point. So we have specified entry point in our Docker file before. Let's look at in detail what is this. Okay, so now here, let's say when we run the Ubuntu image, so it runs an instance of Ubuntu image and it exits immediately, right? So when we see the list of running containers, we see no containers running. Whereas if we see list of all the containers, we see an exited container with Ubuntu, right? Why is that so? As we discussed earlier as well, unlike virtual machines, containers are not meant to host an operating system. Containers are meant to run a specific task or process, like host an instance of web server, application server, database server, or simply carry some kind of a computation task. Now, once the task is completed, the container exits. So the container lives only as long as the process inside it is living, right? So if the web service inside the container is stopped or crashed, the container also exits. So who defines what process is run within the container? So let's look at our Docker file. Let's look at Docker file for Nginx, and we'll get to know more about it. So we see an instruction called CMD. CMD defines the program that will be run within the container when it starts. So for the Nginx image, this is the Docker file. I have just specified a screenshot. Here at the bottom, you see CMD instruction. And here we have Nginx as the process which is running. Now, if we look at the MySQL image, we see MySQL D as the command which runs in the MySQL image. So these processes or the command which is specified over here keeps the container running. Now, looking at the Ubuntu image, so when we run a container with a plain Ubuntu operating system, we look at the Ubuntu image and see the CM command which is written over here is bash. Okay, not a process which can keep it active. It's only a bash command which is specified here. Now, bash is not really a process like the web server or database server, like Nginx or MySQL-D. It is a shell that listens for input from a terminal. If it cannot find a terminal, it exits. So when we run the Ubuntu container, the Docker launches the bash program. So by default, the Docker does not attach a terminal to a container. So the bash program does not find the terminal and it actually exits. So this is what is happening at the background when you run the Ubuntu image. Now, what if I want to specify a different
Sir, can
command?
you explain that again?
Can you repeat the question?
Can you explain that again, sir?
Yes, yes, Brian. So now going back to my cmd. So here this is clear, right? So in Nginx we see a command which says run Nginx. So and in MySQL we see a command which is running MySQL D. Nginx and MySQL D are processes which runs, okay, when you execute this command prompt. Whereas in Ubuntu, what happens, the default command which is specified is bash. Now, talking about bash, bash is not a process like the web server or database server. That means bash is not a process like Nginx or MySQL D. It's just a terminal. It's just a shell that listens to the input from the terminal. Now, when we run Ubuntu container, it basically first check for the terminal. And if it cannot find a terminal, it exits immediately. So that's why to run Ubuntu container and get inside it, we execute exec IT. IT is for interactive terminal. So when we are running Ubuntu, we are actually providing the terminal for the Ubuntu container to keep it active. So if we do not provide the -it and the exec command, what we get is when the Ubuntu container runs, Docker runs the bash program or Docker launches the bash program. But by default, the Docker does not attach a terminal to it, right? So that's why if the bash program does not find the terminal, it exits and the container goes to the exited state.
Okay.
Okay. Now, yesterday we spoke about if you want to specify a different command at the start, like a sleep command, what we can do is docker run ubuntu sleep. Now, when we specify this, it overrides the default command specified within the image. So when the container start, it runs the sleep command or sleep program, which sleeps for 5 seconds and then it exits, right? So instead of sleep command, it can be any other command as well here. Now, how do we make this particular change permanent? If we want our Ubuntu image to always sleep for 5 seconds. So let's see how do we do that. So for that, we need to create our own image. So now we are going to create our own image and we will see the difference of that. Now, let me just connect to the terminal. Okay, so in the meantime, all of you can create this particular image. So this is your Docker file, which is from Ubuntu CMD as sleep 5. Okay. So create a Docker file within your Linux VMs. I'm creating a directory, which is my sleeper directory. Here I'm going to create a Docker file. And then I'm specifying from Ubuntu, and then I specify the sleep command, okay, which is sleep, and then I say exit. So this is my Docker file. Now, if I build this image and run this particular container, now when the container runs, it will sleep for 5 seconds. So there are different ways of specifying the command, one as a shell or another in the JSON format. So in the shell format, I can just specify the commands like this. When I specify in the JSON array format, so within the brackets, I have double quotes, and every command is specified and separated by a comma here. So one way of doing this is cmd sleep 5, another using the JSON array like this. Okay. Now, remember when you specify in a JSON format, the first element in the array should be the executable. So here, sleep is our. So this is something which you have to remember when you specify JSON format. Now let's try to build our image and then run our image.
Sir, so in case of multiple commands,
So
how
when
do
I
we do?
Yeah, so you specify only one here. So it cannot be multiple commands running your processes.
Okay.
Okay. So I have Docker file here. Let me see this Docker file content. So I have it specified like this. And I provide this command docker build. And then I'm saying Ubuntu sleeper. Okay, Ubuntu sleeper is the name of my image. Okay. Now this particular thing will build this sleeper image. Now, as you can see, the image is built successfully. If I go to Docker images, I can see Docker image Ubuntu sleeper. Now to run it, I can just type Docker run Ubuntu -sleeper, the name of my image. Okay. So now when I run this, you notice that it sleeps for 5 seconds and then it exits, right? But if I want to change the number of seconds it sleeps, how do I change it? Right now, it is hard coded to 5 seconds. But what I want is I want to pass the number of seconds the container should sleep, and sleep command should automatically get invoked. So the correct way of doing this is using entry point. Okay. So now here we are going to look at the difference between the entry point and command CMD. So the entry point instruction is like the command instruction. You can specify the program that will be run when the container starts. Whatever you specify on the command line will get appended to the entry point. Okay. So let's replace CMD with the entry point in our Docker file. Okay. Before that, if I just specify like this, Docker run Ubuntu sleeper and then 50. So it says 50 is not a command. Okay. Now I'm going to edit my Docker file and I'm going to put the entry point instructions over here. And I'm specifying in the JSON format. Okay, so here I see sleep as a command. Okay. And for now, I've commented my CMD command. Okay. I basically write on this file, means I save this file, and then I do a Docker build once again. Okay. So on the same Ubuntu sleeper image, I'm just going to build it once. Now the image is built and you see only the entry point is updated over here. Now I'm going to run the Ubuntu Docker Ubuntu sleeper image, and here I'm going to specify 50 right now. Now when I specify 50 here, I can see that my Ubuntu sleeper image is sleeping for 50 seconds. Whereas when we used CMD command, we didn't get this flexibility of specifying the number of seconds, right? So to summarize in one line, when you use CMD, the command line parameters passed will get replaced entirely. Whereas when you use entry point, the command line parameter will get appended. Okay. So CMD was specified in our Ubuntu base image itself when we wanted to completely replace that with a sleep command. We were able to do it. Okay. So now let's look at one more thing over here. When I was only specifying CMD, I was able to run the Ubuntu sleeper and that was sleeping for 5 seconds, correct? Because I had this command specified over here, it says sleep 5. But when I'm specifying entry point and I'm not passing the number of seconds here while running the Docker command. So it says sleep missing operand. That means it is expecting something to sleep. So let's look at the next few things. Then it gives an error like I showed you here. So how do I configure the default value? Okay. How do I configure the default value for sleep? Let's say I want to make an image, Ubuntu sleeper image, which sleeps by default for 5 seconds if nothing is specified. But if some user wants to override that with the number of seconds, he can override. So how do I do that? So in that case, we can make use of both CMD and entry point. So the CMD instruction will be appended to the entry point instruction. The command at startup by providing this will now be sleep 5. So let's try making this change in our Docker file and observe this. Now I'm editing my Docker file over here. Okay, so I have the CMD entry point command, which is correct. Now I only change my CMD command, and here I specify 5 seconds as a default sleep command. Okay, so now it will execute sleep and then the CMD, which is 5. So let's save and exit. And now I'm going to build my Ubuntu sleeper once again. Okay, so I have to correct my Docker file. I did not specify the double quotes. Okay, so now I'm building my sleeper image once again, and Now, if I run the Ubuntu sleeper command once again, without specifying any additional argument. So I notice that it sleeps for 5 seconds, right? Whereas if I want to override that and sleep for 15 seconds, then I can just specify like this and there is no error which is coming up here. Okay, and I see that Ubuntu sleeper image or container is sleeping for 15 seconds. Okay. So that's how you can make use of both entry point and CMD. So in entry point, you should provide the steps or commands which will run for sure 100%. And in CMD, you have to specify some of the additional arguments with respect to that command, like sleep 5 here. Okay. Now, CMD command, what you specify can be overridden at the while running the Docker container. Okay. Now, one thing to remember here is this will only work if you specify the entry point and CMD instruction in the JSON format. It won't work if you specify in the shell format. So while writing Docker file, it is recommended that you use JSON format in entry point and CMD. Now, for some reason, let's say if we want to modify the entry point during runtime. So let's say change the sleep command to an imaginary sleep 2.0 command. So we can override it by using the entry point option in the Docker run by specifying something like this -- entry point, then the command which we want to override. So sleep will get overridden by sleep 2.0 here. Now command at startup will be sleep 2.0 and then 10 seconds, which is we are overriding. Clear? So that is the difference between the entry point and the CMD command. So is this clear?
Yes.
Okay. So now let's take up some exercise regarding the CMD and entry point. So I'm just sharing the link on chat. Okay. Right. So now let's do this exercise. I think it should not take more than 5 or 10 minutes. Is it done?
Yes.
Mine is done.
Okay.
Yes.
Okay. Right. So we'll get started with the next topic, which is our Docker volumes. So we covered volumes on a very high level yesterday. Now we will look at some details about it, or Docker storage, I can say. Okay. Now, talking about Docker storage. So on installation of Docker, it creates its folder structure under var lib docker. So this is where Docker stores all its data by default. So if you look at var lib docker here, you can see a folder structure which is having volumes, which will have all your Docker volumes, images, containers, and EUFS. So EUFS is the storage driver, so that differs based on the operating system what you use. Okay, so if I go to cd/var lib docker, I can see this folder structure over here. Okay, so I get this folder structure. Now, we discussed just now that Docker builds images in the layered architecture. So each of the image, each of the layer has its own size. Now, we spoke about that with one particular image, but that's applicable for the second image as well. So if you look at this Docker file, which is on the left, so I have this Docker instruction which is specified, more or less similar to the Flask application which we looked at. Now let's consider a second application. This application has a different Docker file, but it's very similar to our first application. So it uses the same base image as Ubuntu, same Python and Flask dependencies, but now this time it uses a different source code. So it is using app2.py, right? Now, when I run the docker build command to build a new image for this application, when I run this docker command, now Docker is not going to build the first three layers, since the first three layers of both the applications are the same. Instead, it reuses the same three layers it built for the first application from the cache and only creates the last two layers on which my source is getting changed. So this way Docker builds images faster and efficiently save disk spaces also. This is also applicable when you update your application code. So earlier when we updated our application code, we saw that the Docker does not build the first three layers. However, if you have multiple applications or multiple microservices also using the same kind of layers, the Docker is only going to build the layer which is having a change, and it will reuse the existing layer. So that's about the Docker layered architecture. Now, all these layers are created when we build the Docker image. Now, these are called the image layer, all the layers what we see here. Once the build is complete, content of these layers cannot be modified. These layers are read-only layers. So that's why when we had to modify the content, we kind of built our image once again. So these layers can be modified only by initiating a new build. So if you change something on app.py code, some code level change if you make, You have to rebuild your image to reflect, to get that change reflected. Okay. Now, what happens in background when we run a container? Docker creates a container from these layers and also creates a new writable layer on top of the image layer. So here we have this read write layer, and this is called as container layer. So here we have the image layer. When we run the docker run command, it creates a container and it also creates a container layer here. Now, the writable layer is used to store data created by the container, such as log files, temporary files, or just any file modified by the user on the container. Now, the life of this layer is only as long as the container is alive. When the container is destroyed, this layer and all the changes stored in this layer is also destroyed. So let's say, for example, we have this app dot, okay, let's say we log into our newly created container and create a new file, temp.txt. Now this temp.txt will get created in the container layer. It will not get created in the image layer. Now our application code is in the image layer, suppose, and in simple web app Flask container or image, we saw that we have app.py, which we were copying to our image while building it, right? So does that mean if I want to modify my app.py code after running the container, can I not modify? Okay. So if I wish to modify the application code, how will it work? Because our image layer is read only.
We will create a new image.
We can create a new image to modify the application code. Correct? But what other thing which I can do? Or the question is, if I want to modify this app.py code, will I be able to modify or no? Within the
Why?
container, after running the container.
No. Then we'll have to exit the container, make changes, build it again, and then use it.
Okay. So the answer to that is I will still be able to modify the app.py code within my container. So we can go into the container, right? By exec it and then bash. And then whatever modification I do there in app.py code, my app.py will get modified. But before I save the modified file, Docker automatically creates a copy of the file in the read write layer. So actually we are not making any modification in the image layer. When we just save it, it creates another copy of it. And this mechanism is called as copy on write mechanism. Now, by this, it allows us to modify the application code, and all future modification after running the container will be done at this container layer and will not be done at the image layer. Okay.
Sir, so the next time if we use this image, the modifications won't be there in this app.py. And again, if you want to make some changes, you'll have to make it again. If we just use this
Correct.
image. Okay.
Yes. If we follow this approach, the modification will not be present over here. Okay. Now, image layer being read only just means that the files in these layers will not be modified in the image itself. Image will remain the same all the time until you rebuild it. Okay, so your image is not going to change. So is that clear? Do you want to perform a quick hands-on and want to see this? Or is this clear at a knowledge level? Okay, fine. So to so that says that you can relate when you created the Jenkins image, or when you created a container using Jenkins image yesterday. So we installed a lot of plugins and all, right? So those are some of the modifications. Actually, it did not come in the container layer by default, but we made that change. So basically we wrote something over here. So there may be Jenkins configuration, which tells me that the user files are there or no, or some of the port configuration or plugins. So we actually modified it. All those modification happened here. Okay. Now, when we exit the Jenkins container, all these modifications will go away. So that's our next thing. What happens when I delete the container? All data stored in the container layer also gets deleted. The changes we made to the app.py and temp.txt will also get removed like this. Now that's the reason we used a volume yesterday, so to persist our data. Okay, so how do we persist our data? So we have used volume for it, and this concept was made clear in fact yesterday. So let's say I want to run my MySQL and my database to be persistent. So this is my MySQL container layer, and I want to write my data within this. So in this case, we can add a persistent volume to the container. So inside varlib docker, I have this volume folder. So what I can do is I can create a volume with name data underscore volume. This is just an example. Now, when I do this, it creates a folder called data underscore volume under varlib docker volumes. Okay. So is this clear? Now, varlib MySQL is the default location where MySQL stores data. So this is the default location. Now to persist data, I can mount this volume to MySQL default location while running the container. So what happens is I provide -v data underscore volume. Now data underscore volume is within the volumes, so we don't have to provide the full path. By default, Docker considers that full path means this as the default path for volume, colon our container volume, which is this /var/lib/MySQL, then the name of my container. So all data written on database is stored on the volume created on the Docker host. Even if container is destroyed, the data will be available. So even if this container dies, this volume data underscore volume will be available. Okay. Now, what if you directly run the container without creating the volume? So in the previous step, you see that we created a volume first, data underscore volume, and then we mounted it while running the container. What if I don't do that? To persist data, I can mount this volume directly to the container. Now, if I do not create the volume first before running the docker run command, Docker will automatically create a volume named data underscore volume 2 and mount it to the container. This is also called as volume mounting. So if I run this particular command, here the volume name is volume 2. Now inside this /var lib docker volumes, another volume gets created and it is automatically mapped to the container.
Sir, suppose we run the container first. So after running the container, can we map the volume?
Now after running the container, you will not be able to map the
Okay.
volume. Okay. So this is, remember, this is called volume mounting. When you are having volumes within the default Docker volumes folder. Now, what if our data is already present at another location? Let's say data. Okay. So I'm this my MySQL volume is already present under /data. We would like to store database data on /data and not in the default location. So we can create a container and provide the complete path of the folder, which is /data/MySQL. This is something which we did yesterday. And this process is called bind mounting. Okay. Now, bind mounting is most popular compared to the volume mounting because you can specify your custom location over here. So clear? Now, hands-on on this we have already done yesterday. I hope that volume mounting hands-on is clear. If not, you can perform it once again if you want to. Was that clear, the volume mounting yesterday?
Yes, sir.
Yes.
Okay.
Yes.
So, yeah, one more thing. -v is an old style for mounting where you have to specify it in this format, key value pair format. -- mount is the preferred way as it is more verbose. Basically, in this -- mount, each parameter can be specified in key equal to value format. Okay, so if you use -- mount, you can specify it as type equal to bind or type equal to volume can be here, and then source equal to /data/MySQL, comma, target equal to /var/lib/MySQL. This is the preferred way of mounting it. Both does the same thing, but people prefer this -- mount where they can specify in key and value format. But talking about me personally, I found this more easy, -v and then the verbose for sorry, the -v and then /data : the container volume, host : container. So this is personally which I like, but people follow the -- mount a lot in the industry.
Sir, so in this command, for type, if we write volume, then we don't have to specify the source part.
Yeah, source you have to still specify, but you need to give a name to the volume. So you can give anything like ABCD or MySQL volume here in the source. Okay, now some of the useful commands with respect to volumes are this. So To create a volume, I can type docker volume create, then the volume name. To list the volumes present, I can say docker volumes ls. Okay, so if I say docker volume ls, I see that I do not have any volumes created for me right now. This is my new instance. That's why if you execute this particular command, you will be able to see some of the volumes. Okay, now to inspect a volume, you can type docker volume inspect and the volume name. To remove a volume, you can type docker volume rm, then the name of your volume. So clear? Now we can take up some exercise specific to volumes. I'm sharing the URL in chat window. Now this volume exercise can take up to about 10 or 15 minutes or so. Okay. Did you get the URL?
Yes.
Yeah, okay. Is it done?
Sir, 1 minute. I'm still.
Yeah.
Yes, and now it's on.
Okay. How about other people? Done?
Sir, I'm still done.
Done, sir.
Done.
Okay. Yeah. We'll wait for some time to finish, to allow others to finish. Okay. So okay. In the meantime, just a few updates that tomorrow, that is 21st, you're going to have domain discussion from 5 p.m. to 6 p.m. Okay. And 28th will be another domain discussion. Now, talking about the assessments. So you will have assessment from 4:30 to 6 p.m. on the following dates. So Jenkins and SCM will be on 24th August. Docker and AWS on 27th August, and Ansible on 31st August. Okay, so this is the updated assessment schedule. I'm also putting that on the chat window.
So what will be domain discussion?
Domain discussion, as far as I know, is based mostly about the MADS policies and procedures. How is the HR policy, and I think all of those things. Okay, so people from MADS will take it.
Okay. And the assessments would involve hands-on, or it's going to be an MCQ test like we had it in the Skillshare portal?
Okay, so there will be MCQ, and there will be some descriptive questions also.
Okay.
Like, to give you an example, what is the difference between declarative and scripted pipeline? So something like this.
Okay.
And there will be some questions where you will be asked to write a Jenkins file or something like that.
Okay, got it.
Okay. And with respect to SCM, Git commands and all those things will come. Okay, so mix of all the three types.
Prabha?
Yeah.
Can you share the OneDrive link for the PPTs? Actually, yesterday I was not able to access it. It was saying access denied.
Okay. Sure.
Yeah,
I'll
even I was
send
not
it.
able to access.
Okay. I'll do one thing. I'll send it in WhatsApp itself, because these chats goes away. Okay.
Yeah, Prabhav, also like for the Skillshare platform, I'm not able to log in. Like they have given a sample ID and password. For me, it says invalid ID or password. That amddevops@2020.com.
Okay.
So when I log in using that, it says invalid and I'm not able to see any of the recordings.
Anybody else also having a similar kind of issue?
Yeah, yes, sir. Sir, I'm getting Microsoft this not found video not found, so nothing is coming for that.
Oh yeah,
It's
same.
actually not working in Chrome, but I tried in Firefox, and there it is allowing us to log in Microsoft Stream.
Okay. So Mahima, we have to use this like Firefox to for that
So
email ID and
login,
password.
yeah, login using your login to Skillshare like you normally do, and within Microsoft Stream you have to enter the sample password that they've given.
Okay, because in mine, it just says the video will be uploaded soon and nothing else.
Okay. So what we can do is, if you want me to have a look now, any one of you can share the screen and we can quickly have a look. And another thing is, Firefox is actually not needed. I think what's happening is there is a separate credential for Stream, and in MADS you have having a separate credential related to MADS. So I think that's conflicting if you're opening that on Chrome. And so if you don't have Firefox, you can open an incognito window in Chrome itself and try to put that credential.
Okay, I'll try that.
Yeah. Okay, So just try that out, and if in case you're having any issue, just let me know. Okay, so now moving on. Before breaking for lunch, we will finish one more topic, which is Docker networks, which is a very small topic. Okay. Okay, so we have been accessing our Docker containers, but we have not spoken about the Docker networking yet. So let's talk about it now. Okay, so when you install Docker, it creates 3 networks automatically. So the 3 networks are bridge, none, and host. Bridge is the default network for your containers. Now, to associate the container with any other network, we can use the network command line parameter, which looks like this. So Docker run Ubuntu. Let's say I want to run this -- network equal to network name. So if I want to connect it to bridge network, I don't have to specify the network details. But if I want to connect to the none network, I'll say -- network equal to none. And for host, I'll say -- network equal to host. Now we're going to look at the details of each one of it, or what these are about. Now, starting with our default network, which is the bridge network. So bridge network is a private internal network created by Docker on the host. All containers attached to this network get an internal IP address, usually in the range of 172.17.x.x. So if you notice, our container IPs are also like this: 172.17.0.2, 4, and 5, something like this. Now, containers can access each other using these internal IP addresses if required. So it by default allows communication between the containers. Now, to access these containers from outside, we map the port of these containers to port on the Docker host. So this is something which we have been using so far, like mapping our web container, which is in 5000 to port 80. So we specify -p 80:5000, right? So this is something which we have been using so far for our port mapping needs, or for our networking needs of Docker. Now, coming to the next network type, which is my host network. So this is your host network. Now, another way to access the container externally is to associate the container to host network. But it takes out any network isolation between the Docker host and Docker container. So if you run a container, it is automatically accessible externally on the same port, because we are actually using the host network itself, not the container network as such, right? So when you run a container, let's say run a simple web app container. So you say Docker run -- network equal to host, then space simple web app. So in that case, you do not have to specify any of the ports and all. The default port which will be exposed, that is 5000, will be mapped for the user traffic to get routed. But in this case, with this network, we will not be able to run multiple containers on the same host on the same port, because that will lead to port conflict. So if I'm spinning off another container and using the host network again, I'll not be able to create another container or run another container with this. So is this clear difference between the bridge and the host network?
Yes, sir.
Yeah. Okay. Now talking about another network type, which is none. So the containers are not attached to any network when you specify it as none. Now containers do not have any external access when you specify it as none. Containers even cannot communicate with other containers over here. They run in an isolated network altogether when you specify this. Okay. Now, if they cannot communicate to the users, if they cannot communicate to the other containers, what will be the use of the containers which I create with none network? What can be the use of this? Okay, so none networks are used with the containers which are meant for some of the batch processing or file processing and other stuff. So they don't have to actually get connected to any network. They get the files in the storage, they process it, and then put the output, and that's all. They don't need to connect to any network. In such cases, you can use containers with a none network. Okay, now, so we have seen the default networks which is present in Docker, but in Docker, we can also create our default network. So by default, Docker creates only one internal bridge network. If we wish to isolate the containers within the Docker host, I can create my own custom network or user-defined network. So in this particular scenario, I have my first two containers in the 172.17 series, whereas the other two containers I have in 182.18 series. In that way, they will not be able to communicate to each other. Okay, so this is how you can isolate the applications or containers in the Docker. Okay. Now to create a user-defined network, the command which you can use is docker network create -- driver. We have to specify. Driver can be bridge, host, or none. The default what we get while installing the Docker. Then -- subnet, and I can specify what subnet I want in for this new network. And then finally my network name. And if I execute this particular command, I can see the list of networks by typing docker network ls. So here I'm going to create a network. And I'm giving a name as test.
Yeah, sir, in the last, the /16 means only 16 hosts can be there. Means there only 16 containers can be there. What does that mean?
No, so this is like a subnet mask which I'm specifying here.
Okay.
So let me show you this. I'm just opening the subnet calculator. Okay. So this is my online subnet calculator. Okay. Here it does not have anything. Okay, let me open a different one. Okay. So let's say I give this as an IP address. and I provide /16. Okay, so if I calculate, where is it showing? Okay, so yeah, here it says now this means a maximum of 254 or 255 hosts I can have. So the IP address will start from 0.1 and it can go till 182.18.255.254. I specify this as 8, or let me specify it as 32. So when I specify this 32, you can see I can have only one host. Let me specify this as 24. Okay, so 24 is to 55 host. Okay, let me specify 16. Okay, so 16, you see, I can have more than
half. Okay, yeah, got it.
the 255 hosts. Okay. So this is the network which I'm creating over here. Now my network is created. I can type docker network ls to see the list of the networks. So you can see this is a test network which is created. Okay. Now, if I want to inspect the IP of a specific container, I can do that. Or if I want to inspect the network of a container, I can do docker inspect, then the container name or the ID. This we have already seen yesterday. Okay, so this is about the Docker network. Now there is another thing to note here is, let's say you have two containers running on the same node. One is your web container and second is your MySQL container. Now my web container here is having the IP address of 17.0.2. MySQL is 17.0.1.